Okay, let's see who's here. Timmy's here. Ben's here. Jonathan. Jonathan? Nope. And Ariel. And Zoe. And Lisa. Question?
Yeah, I kind of forgot how to do like the structures. Would this be right?
So you did that. Once you're done with that, your Lewis dot diagram for both of these isn't quite correct. So let's check your Lewis dot diagram for these. Your Lewis dot diagram there is not correct. Do you have a pencil? Here, I got one. No, I do not, because that's broken. Bring me one. Okay. So what you do is whatever element it is, let's say element X. You start at 1, you go 2, you go 3, you go 4, and you just put one at a time. 1, 2, 3, 4. And then you start doubling up. Okay. So good. That one's good. But that one, it has an empty spot. And there's no way you should have an empty spot. So I'll do this one. You would start at the top, you go, it has a total of 5. So that part's correct. So you go 1, 2, 3, 4, 5.
Okay.
And the reason why that's important is when you get to here, with the correct diagrams, you're going to have an easier time trying to figure out where it makes bonds. And this first one is like one of the tricky ones we did in class, like it has multiple bonds. So there's a hint. But if you want to start with like easier ones and get into it, like that one, and I think B and CH4, but let's say if we did carbon, it would be 1, 2, 3, 4. And oxygen is 1, 2, 3, 4, 5, 6. And then you start matching up unpaired.
Oh.
Okay. Now, if you run out of ones to match, like that could match, but all of a sudden you got unpaired and paired. You can start breaking them apart to pair them.
Oh, okay.
Try that. Where was I at? I was at Lisa, and then Felix. And Zane is not here. Matthew is gone to the washroom. William K. Not here. Alejandra, Bertie, Zachary, Karen is not here. William R, Naomi, Hugo, and Sahir. Excellent. Okay, if you could put the worksheets away, put them away, take out the notes I just handed out. Let's do some chemistry and I'm going to do some demos. That needs work.
Oh no, sorry, we know. I meant
It can't be rolled like this, or I have to put
That's fine.
You know, I meant to put these on.
Okay. There you go. Okay, worksheets away. Worksheets away. Worksheets away. Pull out the notes that look like this. Bertie? Notes that look like this. Good to go. Excellent. Okay. Just waiting for everybody.
Is that right?
It's not atomic, because atomic would imply nuclear. So the first type of change that we are going to do is going to be a chemical change. Well, where did it go? Why? Oh dear. 1 second, my pen is forcing itself onto the other page. Work area. Play 1. Bring it back. Apply. There we go. Okay. So chemical change. I'm going to bring on some demos. We'll look at a chemical change. Chemical change, we get something new. And with new properties. It always involves a change in energy. Where is the energy in a molecule? If I have H2O, which you've been drawing now for a little while, where's the energy in that?
When it connects.
Where it connects. So the energy is in the bonds. So we have to break bonds and we have to form bonds. Not bonds, but bonds. Now I'm going to guess, and I may be completely wrong. Did you do the clues to a chemical reaction last year in grade 9? Some of you kind of. Can someone give me one clue that a chemical reaction has occurred? Okay, I'm going to go from the back to the front because I think that was the order of the sentence. So there, there, and there. Go. Did you say sizzling? And like fizzling. That's actually two things. I'm only going to take one of them. So, no. The sizzling and the fizzling both refer, you could just say one of them. It still refers to two things. Why keep drawing in red? So, sizzling. Do you spell fizzling with that many I's?
Is fizzling even a word?
English is defined by common use. If you use it and you get enough other people to use it. For example, how do you pronounce that word? It's obviously GIF. Yeah. But some people, some benighted heathens say GIF. And the author of that word says it should be pronounced GIF. 80% of the English-speaking world pronounce it GIF. Therefore, it's GIF.
Yeah.
It's solely due. Now, if we were in France, that's different. France has said that the French language is defined by an institute, and they're allowed to say anything. So they just make up the rules, and technically that's correct. There is no institute for English. And when you realize there are more English speakers in the world who are English as a second language than there are English speakers who have English as a first language, then if the entire world wants to change English, they can just do that. It's done. Anyway, I'm going to say this is the sound. So if you hear a sound, which is this is an energy change.
Wait, but couldn't that be a physical change as well? The sound is
Oh, we're talking about clues, not 100% evidence. So could a physical change have sound? Yes. Yeah. Okay, moving up. Who is
I'd say a change in color, an appearance.
changing color? I'm going to start doing this. Do you know what this means? Change. What did you say? A what? Divide? I haven't heard of that before. Have you seen this? Like speed is equal to the change in distance over the change in time. So it's just me. So I'm just using it here as a shorthand to mean change. So I don't have to write that every time. You can do that too. Okay? And then Matthew? Change in temperature. So again, a change in energy. See here? You had your hand up?
I was gonna say temperature.
Oh, okay. So we got 2 votes.
And what if we did change in light or change in color?
Change in light. Matthew's just yelling them out. Stop doing that. A change in light, and I'm not going to write the other one. Hopefully nobody heard it. So change in light, like literally it gives off light, like a fire. That would be an indication of an energy change. Yes?
Change in, can I say one?
Yeah?
Change in like smell.
Change in smell. Cooking is a chemical process. Everything you can tell by the smell in the air what point in the cooking it is. Now there's more than these, so I'm going to keep going. Let's continue here. Yep. What one did I do? A change in taste. I'm going to put smell/taste because taste is technically smell. Very, very little of your taste is actually on your tongue. Most of it is the chemicals and gases being released in the back of your throat, going up into your nose. If you plug your nose like well, and you cut up an apple and you cut up an onion and then blindfold yourself and have someone else feed you, most people can't detect the difference. Yeah.
Even in the
That's why
texture.
whenever like
Yeah.
you see like people
Cut small pieces so you can't tell, and then yeah,
I mean, onion and apple has like very different texture.
yeah.
And like,
But chop them up so that you can't like get that part out of it. And people have done that. It's one of those YouTube videos that
like,
people think
you
is
ever
funny.
see, like, people eat like something really spicy the whole time? Or it's really good.
Think of a fire, and well, maybe I'll just show some of these.
What about changing like mass?
Ooh, this goes to one. A change in mass is actually wrong
Volume?
Volume.
because sometimes it does change mass, but it's because something's doing what? Yes?
Change in shape.
It's not worth it.
That's volume.
Change in shape is actually often more considered with a physical change. It could change in shape very easily. Certainly when you're cooking it, it can change in shape. But when you mean a change in mass, what is often happening in that reaction?
Air is coming in.
Air is coming in, or
water's evaporating.
water's evaporating, or something's leaving. So
Change in volume.
change in state. Gas given off. A new liquid is formed. Now, can you get a gas given off for a physical change, like boiling water? Sure. But all of these are clues together. And the last one is if I have a physical change, let's take something precious.
Nothing.
Like, not that precious. Like the periodic table. Which I hold dear. I just have to run.
I think it's gonna bother me. 1 second. It's gonna bother me. Is it starting the fire?
Don't touch, no touchy. Never touch anything from the lab without express written permission. Signed in triplicate by your parents. Okay, so
Nice.
physical change, not a chemical change. If I did this,
Yeah, it's starting on fire. This matches.
I have under what kind of change is that?
Physical.
Physical. It's not a new color. It did give off sound, but also, how easy is that to reverse? Pretty easy. In fact, if I was to rip it up, and even if I was to shred it, could I reverse that?
Yeah.
Yeah, you take it together. We are still going through bags of badly shredded documents because they didn't even shred them well. Sometimes it was just ripped 3 times from World War II. As they were invading like concentration camps and the Allies were coming into cities, the Germans were trying to shred all the evidence of all the things that they had done. And we still have bags of it that have never been touched because there's so many documents. So every year we actually have more evidence and more stuff because it's just shredded and patient people can put it together like a jigsaw puzzle. But if the flame speaks to you and looks pretty, what I love about this too is you learn some things about ink. Some of the lettering's still there after it burns.
That's not nice.
Yeah. Now let's go. Can I pick some up? Did I bring a? Here it is. When you pick a piece of it up without destroying it too much. Now once I touch this ash will completely, like right now you can still see a little bit of the ink in there because inks aren't just like organic material; they have like metal in them as well. So some of that sticks behind. You can still see it. But what has changed about the paper now?
smells like.
Well, we got a smell. It smells delicious. It smells so good. I love the smell of burning in the morning.
It changed color.
It changed color.
Just put your finger on that.
Smell it now. You can see the little, but as soon as I do this,
It'll turn to ash.
and it turns into smaller and smaller ash. How easy is that going to be to reverse? Extremely hard. I'm leaving ash all over the room as I walk around as well. I just rubbed it into a notebook. So one of the clues is that it's very, very difficult to reverse. That is not always the case. It's just, all of these clues could not be present. They could present. These are literally clues. The more of them you have, the more likely it is to be a chemical change.
Is it possible to have all of them and yet it still not be a chemical change?
It would be a challenge for me to come up with an example right now. But have you done in biology what defines life?
Yes.
So you have a series of clues. Bertie, maybe you come up one, Dustin. So what are the signs that something's living? Yeah?
Nutrition, reproduction.
Nutrition, reproduction, breathes, growth,
Produces waste.
produces waste. Oh, I haven't, I'm going to ask see here because I haven't gotten him yet. Respiration, so that's breathing again. Reproduction. So if I was to, let's get my favorite periodic table. I'm about to show you life. What does a fire require?
Oxygen.
What were you going to say?
Like your response to the environment.
A response to the environment. So, what oxygen does this require? What gas does this require? Oxygen. What does it give off? Carbon dioxide. It is literally respiration going on right here. We have a gas going in. It's breathing. It's undergoing. It's moving. If I provide stuff to it, it will respond to stimuli and seek out new forms. It just reproduced. Fire obeys all the clues of life, except for one.
Can't life mutate over time?
Gravity.
There's chemical reactions. It still obeys a lot of laws of gravity. I mean, it does go up, but that's because of the food source. I'm producing a lot of smoke. Where's the fire alarm? But someone said mutations, which is really close, yeah?
Goes to the washing.
No, it's producing waste. Like all of this, you could classify as waste as it seeks out new forms. But it's just a chemical reaction because life itself is just a chemical reaction. It's an ongoing chemical reaction. And so all of the definitions that the biologists came up with, the chemists would go like, yeah, those are the signs of chemical reaction. You have reactants, breathes in. You have products, it has waste. There's an energy change. It will react to new stimuli. Now, sometimes that one's harder to do with a chemical reaction because that sought out something, but did it do so consciously? But we know lots of living things that just seem to react to stimuli like a fire does. There's only one that life does that chemical reaction does not, and that is evolve. There's a set of your genetics, we'll do this in biology later, that's keeping track and is making stuff. And chemical reactions don't have that. That itself is a chemical reaction. But we don't have, if you have a chemical reaction that has that, we would definitely say, so we're looking for life on other planets. It's really hard to tell the difference between a chemical reaction and life. So one of the things we have to look for is, does it change over time, like the individual organism? Or is there some sort of code that is reproducing every single generation? We happen to have DNA, but that'll be difficult to decide in other things. They've recently, like in the last 2 weeks, think they might have found signs of life on another planet. And all they found is the evidence of a certain gas. And that gas, they know, is made by some forms of life on Earth. So it's just evidence of a chemical reaction. A chemical reaction that we know is produced by some living microorganism on our planet. And there's no inorganic process that we think would make it. So, but again, could just be a chemical reaction. Let's, before I continue, finish this off, and then I'm going to do a few more demos. So Some of you said, as an example, of cellular respiration. That was perfect. Because you did organelles last year. What's mitochondria?
Power of the cell.
Excellent. You should all just chant that. And cellular respiration is just oxygen in and CO2 out. It is the entire reason for your multiple organ systems. It's your mitochondria, which is the reason you breathe in oxygen. You have to feed all of them. It's your mitochondria why you breathe out CO2. The reason you have a circulatory system is carrying all that stuff around. That single organelle is responsible for like 5 of your organ systems. Oh yeah. If you didn't have lungs, obviously you would suffocate. But in terms of evolution, if you didn't evolve lungs, what would happen?
Well, you could be like a bug instead.
You could be a bug. Bugs don't have lungs. And so one difference is we'd have to be really small because everything would have to diffuse to our cells.
Or like it used to be, bugs are bigger and there's more oxygen in the atmosphere. And then
Yeah. And then because it could diffuse. We can be big with less oxygen. Yeah, because we breathe. And then we force the oxygen to all of our tissues. Whereas bugs have to work on it, pumping it into little cavities, and then it just diffuses into their tissues. That's how your eye works. That's why if you get an injury to your eye, it takes a long time to heal. Obviously, there's not that many blood vessels over your eye. If there were, you wouldn't be able to see out of it very well. So if your eye gets injured, it is relying on the oxygen from the atmosphere to fuel the cells inside of your eye. Which is why if it gets injured, or you wear your contacts for a long time and block off that oxygen, it can feel like, oh, I've been wearing my contact. Well, yeah, your eye hasn't been breathing. Some other chemical reactions you know of. Pardon?
It's pretty high.
That is pretty high. It's pretty high. Any other chemical reactions you know of? Yes. Bertie, you're gonna move. You're gonna move ahead one. Yeah. Yeah, you put up your hand though. It's like an oxygen. Think of anything. Have you ever cooked?
Environmental.
Anything, yeah. What kind of environmental?
Like, is it a chemical change? Or, I don't know, that's physical change. It's like erosion?
Erosion would be an example of a physical change. So I'll take that because we'll put it down here.
or just examples of chemical change.
So give me an example, and if you don't know where it is, I'll put it somewhere. Yeah. Photosynthesis. We used to be able to say and that's when CO2 goes in and oxygen comes out, which we used to be able to, and it's not just oxygen, we also get sugar. And we don't just use oxygen here, we take in sugar. We used to be able to say every single life form on the planet depends on photosynthesis, even obligate carnivores, because they eat animals that then must necessarily eat plants. However, we have found a few hydrothermal vents, and they use a chemistry that is completely devoid of photosynthesis, and they produce life from the chemicals just rising out of the ocean. Yeah.
What if you smack somebody? What would that be? But
well,
we could destroy the cell then. This house
if it's just a smack, most of that's going to be
But can you reverse it?
that's going to be like a physical change. You just pressed into them. Now, could we talk about some detail about the complex biochemistry of the responses going to the smack, particularly the adrenaline that's now being given off by the other person before they rise up to give you a good punch in the face? Possibly, but I don't want to get that complicated. But if you smack something, that's a physical change. I didn't undergo any chemistry there. Any other? Any other? Yeah?
Like digestion, when you're like
Digestion? Do any of you cook?
Okay.
What do you cook?
I help my mum. My mum's a professional chef.
What have you helped your mom make?
Lasagna.
Lasagna. So I'm going to say vegetarian or meat eater? Okay, so browning meat. Browning meat, the browning reaction that goes on bread on the outside or the meat, that is the protein that's doing that. And that is known as the Maillard reaction, and that is where flavor exists. And that is a very complex reaction. The products that are made are then undergo Maillard reaction again, and they keep making. And that's why the flavor will develop over time, and you'll get more of it. the more you do that. So many times when you're browning meat, the brown stuff at the bottom of the pan is kind of sticking to it. You don't want to lose that. You'll throw in some water or throw in some vinegar or a bit of wine, scrape it up, put it in your meal. That's where all the flavors come in. That's a chemical reaction that's occurred, and you want to keep that in your food. If it's completely black, you've now gone beyond the Maillard reaction and gone into what's called carbonization, where you're left behind with pure carbon, and that doesn't taste very good. Oh, I actually have one right here. I forgot to erase it. Neutralization.
Neutralization could go.
Pardon? Excellent. Neutralization. I'm going to show you a few. Let's see if there's... the one I just did up here. Nobody said fire. Fire is known as oxidation. It's only one form of oxidation, but it's a form of it when we react oxygen to things. Okay.
Would rust be one?
Rust. Oh, yeah, rust is a perfect one. Rusting. Rusting is another form of oxidation. What color is rust? Brown. Kind of reddish brown. What color is your blood? Red. Kind of a reddish brown, but more of a brighter red. That has to do with the oxidation state of the iron in your blood. You always have iron in your blood. Yes?
But can't you, like, let's say, copper rust, and rust and copper is green?
Is green. And if we had copper blood, which is why if you see like a science fiction movie and they have green blood, what they're implying is they have a copper-based chemistry, and their oxygen is carried by copper atoms.
Well,
So our blood is red because of the iron. We literally have rusty blood. How many of you have heard that your blood can be blue?
no,
Just so you're aware, that is a complete lie. Your blood is not blue. It is never blue. It goes from bright red to dark red, and that's it. When we color diagrams, we tend to color the arteries red and the veins blue, or the oxygenated blood red and the deoxygenated blood blue. And we do that solely to make our diagrams easier to read in medical school. And people have looked at that and assumed that the blood was actually blue for very good reason. If you look at your veins right now, find a vein. What color is it?
Black.
Yeah, instead of blacky, blue, black. Actually, am I allowed to ask, can you see, because I've done this demo before, can you see your veins?
Yeah, but like there's no color.
There's no color.
It's just
Right.
like
You see a little darker line. And when you see those, like when it has that color, that's actually not its real color. That's just how the light moves through the flesh. So they're not even that color if you open it up. Now, I believed this all the way to university. And when my teacher told me, no, that's not true, your high school biology teacher lied to you, I said, you are wrong. Blood in veins is blue. I was in chemistry at the time. I was working in the summer for another scientist, and I got a nitrogen bag. A nitrogen bag is where you get like a plastic bag. You can fill it with nitrogen gas to do experiments that can't touch oxygen, so you can get a nitrogen-free environment. So I stuck my hand in it in the glove. I tied my hand off in the glove. I ripped the plastic off, so now my hand is in a nitrogen bag. And then I picked off the knife that I had placed in there earlier, and I sliced my hand to see what color the blood was in the deoxygenated environment out of a vein. It turns out it was still red. So I've done the experiment for you. You don't have to do it. Your blood is always red. Yeah.
What about, because I heard some shrimps and animals have like blue blood.
Some animals have different color blood. Yeah, and they will. They have a different biochemistry. Some animals don't use iron. Almost all mammals and most other animals do, but there are some weird crustaceans out there
Yeah.
that use other types of blood. Yeah.
this is on the topic of nervous systems, but I heard that like small bugs can't feel pain. Is that true? Like ants and stuff? Because they don't have any nerves.
Okay. I just have to say this, because if you like small fuzzy creatures and you want to be nice to them, take everything I say with a grain of salt. We don't know. There's many animals where we can say, like, if it's a bug, it's probably programming. So, like, if you put acid down and then the little cockroach runs away from the acid, did it feel the pain? Or did its nervous system say negative stimuli, move, and then run away? And with cockroaches, we're probably pretty comfortable saying negative stimuli. If you have a bacterium swimming in a petri dish, and you put a spot of acid there, it'll swim away. But we can actually explain every process of that, because when its detectors on its cells experience it, they fold in. That causes the flagellum to move to a different direction and just automatically moves like a robot. Lizards don't have a brain like mammals do. If you take a human in which its sight has been broken, not because its eyes are broken, but because it has brain damage. So there's humans with what we call blind sight. And they can't see. They have no conscious perception of seeing. But if you throw a ball at them, they'll duck. And they don't walk into buildings. And they'll duck underneath branches if they're walking down like a street. They're still blind. They can't see. You ask them what to see. They don't know. If you put a computer screen in front of them, you make a cursor move, and you say, which way did it move? They'll say, I don't know. I can't see. And they say, guess. And they guess right, like 90% of the time. That is the type of sight lizards have. It's called, it's access in a different part of your brain. It's not in the conscious part, but it does a lot of your automatic reaction. So if a rugby ball's thrown at you, or you're in field hockey and a ball, you will automatically react. And that is your blind sight. You've trained that in. And it has no part of your consciousness. And so we think that reptiles may not be conscious in the same way that we think of consciousness. They may not feel pain because they have no conscious state of being. But a complex reptile, maybe they have other brain functions. So what I'm going to say is like, maybe it doesn't. Probably still shouldn't torture them just in case. Mammals definitely do. So I'd be a lot more careful with like a mouse than I would with a lizard. Does that make sense? Did that answer your question? Because I wanted to make it up. Okay, I want another demo before the bell goes. I promised you a bunch, and I've only done one. It was just simple burning. So we're going to come up here. Shit, bro. You don't need to put it, no, you can put those back. Don't put it back. I don't have that many of them. He's actually 50. It's so rare that nobody does it. Okay. I think we can know that. A little smaller. And see here, can you check the drawer on the right hand side there? Are there glass stirring drawers in here? Top drawer on the right. I think there might be a bottle that's in my novel. Now we can talk about all sorts of things right now because right now is this. Anything there, see here? Now, I'm moving the aluminum foil. Nope, never mind. I don't need to care of that. Is this a chemical or physical change? I thought I had 5 minutes. I'm in no rush. Yeah. It's like the world's greatest demo. No, yeah. Go back next day. You probably appreciate it. I'm going to say it. This is how much enough butter.
I'm gonna go back to the house and I'm just gonna sleep for 4 days straight. I'm gonna do nothing but sport. No, I do. But I'm just gonna sleep. I'm gonna be sleepy when I'm at the sport.
Oh, okay.
Is it Friday or Saturday?
I mean, if I knock you out and you go to a club, you can sleep for a month straight if you want.
We're first on the league. Beat Spurs 3-1.
And then school.
I'll see you at the open house tonight.
So you coming?
Yeah.
Oh shit.
You're in third. You're expected to be. They're not expected. Exactly.
They're taking oil or do that no.
Yeah, but team for Chelsea expect to be big 6 on these.
Yeah, they should have done it.
The big 15.
If you guys drop points, on one, and then make a quiz, and then tag each question. And then for the bonus, I made a multiple choice question. And told them to go for it. And when I put it, I would say it's and then then you can go in, and this took us a while. So 125. I had to define all of it. Once I did, I could just scan, and then I filled it in on their scan chart and look at my score and scan it in. Record the tags, the issues, the analysis, and then I got that was percentage. One thing I could do is like if you get a row, I could print out like this, just like save a file. They're all the questions in each team. A Mac version I know is listed. I don't know if the ever had it. I'm gonna go online. I don't need modern Macs to run Windows, even like they change the shit. Sept. I can show you at some point. Because then it has like squares on the outside, right up in front of the squares. Marking them. You have to assign all those things to student members. So they had to fill, yeah, so like they had to fill in their own stuff. But for that event, you can print off answer keys with the name of the student member people. They just give you a PDF on it, all like that. So you just have to do student member. And then have some blanks out if they mess up.
I assumed this from your email, but you were not worried about the security vulnerability with iOS on phones. I'm deliberately not updating my phone because I have an app that texts all my voice, and it's not. It has an error.